this assessment, we're asked to identify the bonds formed and bonds broken in a transesterification reaction and estimate an equilibrium constant for the overall reaction on the basis of that. Now the reaction has been color-coded, but I'm going to just point and hopefully I can point to the right spots, but let's make that list of bonds that are going to break. We'll put the broken bonds on the left side. So if we look at the bonds that are going to break, we see that there's a CO single bond. So right about here, this CO sigma bond is going to break in the reaction. Notice that this alcohol in orange has a proton, but notice over here on the right side, it no longer has its hydrogen attached. So we will be breaking an OH sigma bond. So we break CO sigma and OH sigma. What do we form? We'll put that on the right side of the equation. And what you notice is that the blue molecule has the orange H attached to it. So we are forming an OH sigma bond. And now the orange alcohol is attached to the carbon of the carbonyl. So we've made a CO sigma bond. If we look at the bonds broken and bonds formed, we notice that we break a CO sigma and we form a CO sigma. We break an OH of an alcohol and we form an OH of an alcohol. Given that these are basically identical in terms of the bonds broken and bonds formed, we can estimate that for this reaction, we have a delta H that is equal to 0. Now, if we want to estimate the equilibrium constant, what we really care about is delta G. We want to know what delta G is equal to. And delta G is going to be equal to delta H minus T delta S. So in order to estimate delta G, we have to know something about delta S. Well, lucky for us, this reaction involves two molecules forming two molecules, an ester, an alcohol, and an alcohol. And so we can estimate with pretty close certainty that delta S in this reaction is 0. If delta H is 0 and delta S is 0, delta G is going to be equal to 0. And KEQ then for this reaction will be equal to 1. So neither side of the reaction is favored, or they're both favored equally. The concentration of the products and the reactants at equilibrium should be equal.